So we are going to go over wave model assignment number 4 here. So here, the first 3 questions are talking about lenses and using the lens formula. So let's see what we can do here. The next few questions are all about diffraction gratings and dual slit experiments and all sorts of things like that. So we have a 12 centimeter tall object. Okay, so I'm just going to write my information down here again. So I got 12 centimeter tall object. Remember, object's always positive. It's placed 15 centimeters in front of a converging lens. Okay, so my DO is 15 centimeters. It has a focal length of 10 centimeters. So it's converging, so that's a nice little key word there. Since that's converging, that means it's a positive lens. So this is positive 10 centimeters. Determine the image distance, so I want to find DI. The image height, so I want to find HI. I want to find the magnification too. And any of the attributes or characteristics, such as enlarged, diminished, inverted, erect, upright, or virtual and real. So all sorts of different things we can find there. So remember that lenses and mirrors, they follow the same formula as long as we talk about simple lenses compared to spherical mirrors. It should work out the same. So we're just going to rearrange this formula for 1 over DI. So we subtract over the 1 over DO. 1 over DI. I'll pull my calculator here. 1 over 10 minus 1 over 15. We get a nice little math. Enter, enter. So 1 over DI is equal to 1 over 30. Ends up being a positive number. If I do the reciprocal of both sides here, my DI is 30 centimeters. Okay, cool. Positive number. So that means it's going to be a real. So I'm just going to put that, I'll put it over here somewhere. So we have a real image. Since DI is greater than 0, we'll have that. What else do we have here? I don't know too much else, so I'm going to find my magnification. Find my magnification, negative DI over DO. So negative 30 over 15. So we get negative 2. Okay, so from that, what I know now is that it is inverted. Without even trying to find the HI, I can just know it's inverted because the magnification is less than 0. And I know that it's enlarged since the absolute value of the magnification is greater than 0. So 2. It's 2 times larger, but it's upside down. And the last little bit I need to find here is HI, which is going to be M times HO. And what do we get here? We get HO, M negative 2 times HO, that's 12. So you get negative 24 centimeters. Okay, so there's all the information that we needed for that question. Looked pretty good. Here's another one here, but this time it's a diverging mirror, same information, but we have a negative focal length this time. It's the exact same information. We got the HO being 12 again. We got the DO being 15 centimeters. We have the F being negative 10 this time rather than positive 10. We want to find HI, we want to find DO, or DI, sorry, and we want to find M. So we want to find all this. So there's my givens, there's my requireds. So let's go through the math here. So it's 1 over F is equal to 1 over DO plus 1 over DI. Again, I'm going to subtract over that 1 over DO. For some reason, I'm showing more steps than I usually do. This time, I'm not going to show the last step here. So I'm going to go 1 over negative 10 minus 1 over 15. Get a negative number this time. I get negative, ends up being negative 1 over 6. But then I take the reciprocal of that, ends up being negative 6 centimeters. Okay. Negative, got a negative DI, so that means this is a virtual image. Since the DI is less than 0, okay, looking pretty good. My magnification, negative DI over DO, so negative 6, negative 6, I should say. negative 6 centimeters divided by, what's my DO, 15 centimeters. Okay, so I get a positive 6 over 15. So positive 2 over 5. So it's positive, so that means it is erect or upright, if you don't like the word erect for some reason, because the magnification is between 0 and 1. Oh, sorry, that's the wrong one. This is erect because the magnification is positive. Okay, it's diminished, right, because the magnification is between 0 and 1. There, we're talking about like the absolute value again. Okay, so it's a 0.4, so I'm multiplying my HO by that 0.4 to get to my HI. So this times 12, we get 4.8 centimeters. There we go, looking pretty good. Here's another one here. An image is created from a 10 centimeter tall object placed 5 centimeters placed 5 centimeters in front of the lens, is 4 centimeters tall and upright. Okay. So they want to know a bunch of things like what type of lens this is and a few other things here. So let's just list off what we have. We have a DO of 5 centimeters. We have an HO, of 10 centimeters. We have an HI of positive, it's upright. So it's positive 4 centimeters. Okay. What we want to know is we want to know the magnification. We want to know the image distance. We want to know the focal length. We want to know the type of mirror and all the attributes as well. Okay, so once we know the focal length, we can find out the type of mirror. So let's see how we're going to do this. Well, to find the magnification, I would go HI over HO, which would be 4 over 10, so 0.4, or in this case, like the previous question, 2.5. Okay, pretty good. Attributes of the image. Okay, so based on just that, what we know, we already know a few things about this. We already know it's upright because it just tells us. All right, or erect. What else do we know? Oh, we know it's diminished because it tells us to. We just have to determine if it's a real or not. So that's going to be for my DI. So let's do that one here. So remember, our magnification is going to negative DI over DO. We can rearrange this to find DI is negative M times DO. Okay, so negative 2 over 5 times 15, or times 5, sorry. Negative 2. Negative 2. I probably should put proper sig digs in these. I haven't been putting proper sig digs in all these questions up here. Oh, let's go up here and fix that. No, it looks like 3 sig digs. Let's put a couple zeros here. An extra 0 there. An extra 0 there. Extra 2 zeros here. Okay, let's go back down here. Let's put our DI. Oh, we got DI to be negative, so that means this is a virtual image. Since DI is less than 0. Okay. We got the image distance, so that's good. So we got that. We got the magnification, we're good. We need to find the focal length now. So 1 over F is equal to 1 over dou plus 1 over di. And I'm just going to put numbers in this side over here. So 1 over dou, so 1 over 5, plus 1 over negative 2. Math, enter, enter. here I get -3/10. So that means my focal length is -10/3. So -3.33 centimeters. Everything else is centimeters. Okay, so based on the negative part here, what we know is that this is a convex. Oh, sorry, not convex. Diverging lens. Technically, it's a concave lens, but we use the word diverging to avoid confusion. Attributes of the image and the type of lens. Sweet. There you go. So the next few questions here are all about using Thomas Young's dual slit experiment or formulas and stuff to do that. So we have a few different formulas, remember, to use, but there's one that we don't use because of an approximation, a double approximation actually, that we don't want to compound. So one we're going to use here is lambda is equal to d sine theta over n. Okay. Another one that we're going to use is tan theta is equal to x over L, right? That's going to help us figure this out because the other formula, xd over nl, so we try to avoid using this formula as much as possible, right? Because if I know x and L, I can find the angle, and then I can use the top formula, or vice versa. Okay, and if it's a diffraction gradient, you just have to remember our d is the reciprocal of the amount of slits per centimeter or meter.